System calls for files are used to create a file with no data and set some attributes. Delete is used to free disk space. By the open system call, after create, it gets attributes and disk addresses into main memory. Close frees table space used by attributes and addresses. The call read usually reads from current pointer position. Need to specify buffer into which data is placed. Write usually to current position. Append is used to append information at the end of the file. Seek puts file pointer a specific place in file. Read or write from that position on. Get attributes to read attributes. For example, make needs most recent modification times to arrange for group compilation. Set attributes, for example, it may be used to set protection attributes. Rename is used to rename a file. Now we will see an example of how system calls can be used. For example, assume that on the command line it is written copy file abc xyz. This command copies file abc to xyz. If xyz exists, it is overwritten. If it does not exist, it is created. It uses system calls read and write. Read and writes in 4K chunks. It reads by read system call into a buffer and writes by the write system call from buffer to output file. This is the simple program to copy a file. File copy program, error checking and reporting is minimal. There are some lines for including necessary header files. Here is a function prototype for main. This is required by ANSYS C, but not important for our purposes. The buffer size and the output mode is defined. Buffer size is 4K. And this is the protection bits for output file. This is the line for the starting of the main part. Remember that in the command line we have copy file abc xyz. There are 3 strings on the command line. Therefore, argc should be 3. If it is not 3, that means there is an error. And from the command line, these strings are read into array argv. Argv0 is the pointer for string copy file. Argv1 is for string abc. And argv2 is for xyz. Notice that argc is an integer and argv is a character pointer array. We are going to store strings here. We have in file descriptor, which is going to contain an integer value, and similarly out file descriptor, read count and write count are other integers to be used in the program. We have a character buffer of size, buffer size described here. If the value of argc is not equal to 3, then exit with 1. There is syntax error if argc is not 3. Open the input file and create the output file. InFD is set by the return value of the open operation. So it defines what is the file number. Open arg1 or read only. This is the name of the input file and it is to be opened read only. If InFD is less than 0, then exit 2. If the file cannot be opened, then exit. Outfd create argv2. This is containing the name of the output file and output mode. Create the destination file. If out FD is less than 0, exit by exit code 3. If it cannot be created, exit. Then we have copy loop, while true, this is an infinity loop. Read count is set as the return value of the read system call. This is the in FD, buffer and buffer size. Read a block of data from the file described by in FD. If RD count is less than equal to 0, break. Go out of the loop. If end of file or error, exit loop. Write count is set as write out FD. This is the number for the output file. Buffer read count, write data. If write count is less than equal to 0, exit 4. If write count is less than equal to 0, there is an error. Then when the loop is completed because of break due to either an error in the read operation or all the read operations completed and it is at the end of the file, then it continues here. Close in FD, close the file described by in FD, close the file described by out FD. Check if the read count is equal to 0. If it is 0, so there is no error. All the operations are completed. Exit with code 0. This means that there is no error. It is completed successfully. As exit with exit value 5, there is an error on the last read just before the break in the loop. Directories are also files which are used to organize a collection of files. They are also called folders in some operating systems. There are two types of directories: single-level directory systems and hierarchical directory systems. Here, a single-level directory system is shown. The directory is containing 4 files. This is the root directory, and in the directory we have the files A, B, C, D. However, in a hierarchical directory system, there may be several directories placed hierarchically. Directories are shown by squares and files with circles. This is the directory for user A, under which there is a single file. For the user B, this is the root, and it has 2 subdirectories and a file. And under this subdirectory, there is a file. And in the root for the user C, we have a file and a subdirectory, under which we have 2 subdirectories, and under each of them, we have 2 different files. Here we have a single level directory. There is a single directory for all users. And we have these directories and in each directory there are some files belonging to some of the users. There is naming problem and also grouping problem. If 2-level directories are used, in that case there is a separate directory for each user. So in the master file directory, we have user 1, user 2, user 3, and user 4, for example. And in the user file directories, for user 1, we have directories cat, bo, a, test, and under which there are some files. For user 2, there are directories a and data. Here notice that it is allowed to have the same directory name by different users. Here we have a test for user 3 and directories x data a for user 4. In this case, a path name is used to describe the path from the beginning to the file. Different users can have the same file name. It is more efficient for searching, but still there is no grouping capability. In the tree structured directories, in the root we have some directories under which we have some subdirectories, and furthermore subdirectories may have further subdirectories. For example, under programs we have directories P, mail. Mail has a file, and under P we have directories called reorder, list, find, and they have some files. And here we have hex and count containing some files. For a Unix directory having structure tree, the path names are starting with slash, indicating the root directory, and under that, for example, if we are considering the user subdirectory, in that one we have directories for different users. And for example, for gym, this is the directory, and starting from the root, it is slash user and then gym. This is the path to the directory gym. The path names may be absolute. In that case, starting from the root, under that the directory this is the username, then under that Ee442, and then under that another directory midterms, and then this may be a directory answers, or it may be a file under midterm. However, if relative path is used, this is the root directory for the user and under that EE442, and under that midterm, and under that answers. By convention, dot refers to current working directory, and dot refers to parent of current directory. Consider copy commands involving dots. Copy dot slash lib slash dictionary dot. This dot says go to parent directory, which is user. And this dot says that target of the copy is current directory. If instead of this one, if we use copy root user subdirectory lib subdirectory dictionary to dictionary, this works. This is an absolute path and this is a relative path. And also we can use copy user lib dictionary to user dictionary. This also works. In this case, both of the paths are absolute. The directory operations are as follows. Create, this creates directory. Delete, to delete a directory. For this operation, directory has to be empty to be deleted. Open dir, this is to open directory, should be done before any operations on directory. Close dir, to close directory. Read dir returns next entry in open directory. Rename, to rename a directory. Link is used to link file to another directory. Unlink gets rid of the directory entry linked previously. Protection. File owners, creators should be able to control what can be done by whom on the files. The types of accesses are read, write, and execute, and other operations may be append, delete, list, etc. In Unix, the mode of access may be read, write, or execute, as mentioned previously, there are three classes of users on Unix and Linux, which are owner, group, and public. And access mode for each one can be set separately. For example, if read, write, and execute is to be permitted for the owner, we have 1, 1, and 1 for each of them. So this is corresponding to octal 7. For the group access, suppose that we want to give read and write permissions, but no execute permission. So we will have 1, 1, 0, and the corresponding octal value is 6. And for public access, access for the others, if we want to give only execute permission, then we should have 0, 0, 1, which is octal 1. If a user desires to create a group, the user asks manager to create a group, a unique name, say G, and add some users to the group. For a particular file system, say game, or subdirectory, define an appropriate access. Here, we desired to have accesses as given here. So, by the command change mode 761 game, the modes for all the classes are assigned in this way for the file named game. To attach the file game to group G, then change group G game can be used. Also, there are similar access controls in Windows, and for this example, no permission for the guest is given. These are all marked as deny. Then special permissions can be set by using the advanced settings. Here a sample of Unix directory listing is given. For example, in this line, we have, this is corresponding to the file permissions. This is the permission for the user and the group and for the others. And then we see the number of hard links, which is 1 for this file. This is the name of the owner of the file, which is PGB here. And the group for this file is stuff. This is showing the size in bytes. And this is the time for last modification. This is September 3, 8:30. And this is the file or directory name. This is the file name. However, and if this is a directory, we see a slash at the end. And for this sample Unix directory, we have these files and directories under the current directory, which is listed. File system mounting. A file system must be mounted before it can be accessed. The basic idea behind mounting file system is to combine multiple file systems into one large tree structure. The mount command arguments are a file system to mount and a mount point, which is a directory, on which to attach it. Once a file system is mounted onto a mount point, any further references to that directory actually refer to the root of the mounted file system. Any files or subdirectories that had been stored in the mount point directory prior to mounting the new file system are now hidden by the mounted file system and are no longer available. For this reason, some systems only allow mounting onto empty directories. File system can only be mounted by root unless root has previously configured certain file system to be mountable onto certain predetermined mount points. Example, root may allow users to mount floppy file systems to directory mnt or something like it. Anyone can run the mount command to see what file systems are currently mounted. File systems may be mounted read-only or have other restrictions imposed. Suppose that this is an existing file system and this is an unmounted volume to be mounted at the root. Notice that after the mount operation, the other directories and files under them are no more available. This is mounted at root. After mount, the name of this root directory of the mounted volume will become users. We have different type of file systems. We mostly talk of general purpose file systems. But systems frequently have many file systems. Some are general and some others are special purposes. Consider, for example, Solaris operating system, which has tempfs. This is memory-based volatile file system for fast temporary input-output.